The next thing that we're going to be looking at in this section is what's called the quotient rule, and this is how we find the derivative of a quotient of two differentiable functions f and g. And again, this is just another formula that you need to know how to use. The derivative with respect to x of f of x divided by g of x is g of x times f prime of x minus f of x times g prime of x, all divided by g of x squared, as long as g of x is not equal to 0. Now some people like to think of this in a shortcut term as g f prime minus f g prime over g squared. That's how I learned it. Some people like to think of it as the derivative with respect to x of the high over the low, and there's kind of a cute little poem that you can learn. This is the low times the derivative of the high, so they would say low d high, minus the high times the derivative of the low, divided by the low squared, or low. So low d high minus high d low over low. That might help you remember it a little bit. But again, it's important to remember that the derivative of a quotient f over g does not equal the quotient of the derivative, so you cannot do that. So let's look at some examples of how to use this formula. Okay, so we're going to take a look at this one, and this is clearly a quotient. You've got 5x minus 2 divided by x squared plus 1. So anytime you have the derivative of a fraction like this, you're going to want to use the quotient rule. So in this case, I'm going to let my f be 5x minus 2, and I'm going to let my g be x squared plus 1. So this is now the derivative with respect to x of f over g, which we know is gf prime minus fg prime divided by g squared. So I need f prime, which is going to be 5, and I need g prime, which is going to be 2x. So plugging this in, I'm going to have g, which is x squared plus 1, times f prime, which is 5, minus 5x minus 2, that's f, times g prime, which is 2x, all divided by g squared, so that's x squared plus 1 squared. And from there, I just need to FOIL everything out, or distribute everything, simplify, collect like terms, so on and so forth. So this is going to be 5x squared plus 5 minus 10x squared plus 4x, all divided by x squared plus 1 squared. And then I can combine the x squared terms on top, so that'll be negative 5x squared plus 4x plus 5 divided by x squared plus 1 squared, and nothing will cancel, so that is my final answer. Looking at the next one, we've again clearly got a quotient, sine of x divided by x squared. So we're going to let f be equal to sine of x, and we're going to let g be equal to x squared, which means f prime will be cosine of x, and g prime will be 2x. So we know that this is going to be gf prime minus fg prime divided by g squared. So that's going to be x squared cosine of x minus sine of x times 2x, all divided by x squared squared. So I can factor an x out of the top, which will leave me with x cosine of x minus 2 sine of x, and the bottom simplifies to be x to the 4th. And from there, I can cancel one of the x's on the bottom with the one on the top. So my answer is actually x cosine of x minus 2 sine of x divided by x cubed. And that is my answer. Now if you want to divide through by the x cubed, you can, but you don't have to. And one more of these, and we're going to let f be equal to 3x squared minus 22, and we're going to let g be equal to cosine of x. So f prime would be 6x, and g prime would be negative sine of x. So this is going to be gf prime minus fg prime divided by g squared. So this is just my scratch work. So that is going to be cosine of x times 6x minus 3x squared minus 22 times negative sine of x, all divided by cosine of x squared. So I'm going to simplify a little bit. I've got 6x cosine of x, and then I've got a negative and a negative, so that's going to be plus 3x squared minus 22 times sine of x, all divided by cosine squared of x. And if you leave your answer like that, there's nothing wrong with it per se, but you can take it a little bit further. So I could write that as 6x cosine of x divided by cosine squared of x plus 3x squared minus 22 sine of x. I'm going to go ahead and write this one as cosine of x, and I think you'll see why in a second. So this sine of x over cosine of x is actually a tangent, and we know that 1 over cosine is actually a secant, so one of these cancels also. So I end up with 6x secant of x plus 3x squared minus 22 tangent x, and then I've got a secant x from that other cosine. So this would be my final answer. If you left it like this, that's fine as well. You may also notice that you could have, if you wanted to, bring the cosine up as a secant, so you would have 3x squared minus 22 times secant of x, and use the product rule instead. There's two options for this problem.